Lesson 4 practice problems number 1. Match each situation with a diagram. So we got 3 diagrams, and down here we've got the situations. So number 1 says Diego drank X ounces of juice. Lynn drank a fourth less than that. So, hey, it's probably C, right? Right there, fourth less than that. But no, it can't be that. So, I mean, that definitely, not using the right color there, but that's definitely 1/4 of X, right? That's definitely 1/4 of X, but that doesn't show 1/4 less than that. Like 1/4 less would be like getting rid of that one, right? So the best example for number 1, I would say, is that matches up with B, right? Because that's right there, that's missing. And that shows that Diego drank more juice, right? Diego's X and Lynn is Y. And it looks like exactly, like right there, exactly a fourth is missing from Lynn's amount. Right there. So B, right there. B is number 1. Number 2, Lynn ran X miles. Diego ran 3/4 more than that. All right, now in this example right here, it shows that Diego should have more miles, right? Should have a bigger diagram. So we're looking for an example where Y is bigger than X, and there's only one example like that. And I know that kind of eliminates the thinking there, but let's also talk about the math. But yeah, number 2 is definitely got to be diagram A. So let's just get that out of the way, and let's talk about the math here. So Lynn ran X miles. All right, so there's Lynn's X miles, all right, which are broken up into fourths, right? Those are broken up into fourths, and Diego ran 3/4 more than that, 3/4 more. So every one of those little boxes, oops, not 3/4, so altogether they're 3/4. That's 1/4, that's 1/4, that's 1/4. Together, that makes one happy 3/4 right there, which kind of makes sense because that's farther, right? And process of elimination, deductive reasoning tells us that C should be 3, right? Diego bought X pounds of almonds. Lynn bought a fourth of that, which is very much, it sounds like number 1, but that is more of the example there. That makes sense. So Lynn bought X pounds of almonds. I almost said diamonds. But Lynn bought only a fourth of that. That is definitely, right? That's definitely a fourth. See? Right there, it matches up perfectly. Fourth, there's another fourth, there's a fourth. There it is. Number 2, Elena walked 12 miles. Then she walked a fourth of that distance. How far did she walk altogether? Okay, so let's just go ahead, before we even start looking at all these scenarios, let's go ahead and just kind of draw, I'm going to draw a picture. You don't have to, but I'm going to draw a picture of Elena's walk. Okay, so Elena, right there, walking. It looks like she's running, but whatever. Brisk walk, perhaps, right? But Elena is walking, and her hair is now it looks like she's definitely running. But whatever. All right, so we got that, and so that distance right there, that distance represents 12 miles. All right, and then she walked another fourth of that distance, so 1/4 of that distance. So what I'm going to do is, since it's a picture, I'm going to break it up into fourths. I don't like where I put that. How about right there? It wasn't much different. But there it is. I broke it up into fourths. So those are all fourths. So right here, I'm going to make a length right there that is about the same length as a fourth. And I'm just going to drop that right there. I mean, I guess I could put it right there, but it makes it look like it's longer. I just want to make sure it's differentiated. It shows it's not part of that original number line, But for the miles, for original walk, it's really easy to break that up into 4 equal parts. 12 divided by 4 is 3. So that's 3 miles, that's 3 miles, that's 3, and that's 3. And so this was also 3, so that makes 15. So 15 miles. All right, so now when we start looking at the choices, whether we know what the expression should look like, let's say we have a tough time with that. If you want to just start answering them, just start answering those questions, you can figure out now, which ones add up to 15, or not just add up, but end up with a result of 15. Some of them are multiplication, some of them are kind of combination, some order of operations are involved. So let's kind of go through there. So or choice A says 12 plus 1/4. Now 12 plus 1/4 is just going to be 12 and 1/4. That's not 15 miles. So get rid of A. That's not one that applies. Now I can see what's going on with B. I can see what they mean, but that doesn't work either, because 12 times 1/4, 12 times 1/4 is going to be 12 over 4, which results in 3, right? So that results in the amount, right, that extra part that she walked after the 12 miles. So that can be an easy one to kind of mix up there, but that's not going to equal the total walk. Okay, so we're looking for how far did she walk all together. Keywords here are all together. So all together she walked 15 miles. All right, so for C, we've got 12 plus 1/4. Now 12 plus 1/4, 12 plus 1/4, that's 12 and 1/4, right? But you should be screaming at your screen right now, going, don't do that. That's not order of operations, right? Don't do that. Order of operations tells us that we better multiply first, right? We better do this part first. So 1/4 times 12, 1/4 times 12 is 3. All right, sloppy math right here. But 12 plus 3 is 15, isn't it? Isn't it 15? It is. It is 15. All right, so there is a choice that applies right there. All right. And now for D, you got 1 plus 1/4 in parentheses. Do that first. Order of operations tells us parentheses come first. Or, I guess we could distribute 12 times 1 and 12 times 1/4. We could do that if we want to be all fancy, but let's not make this more complicated. 1 plus 1 and 1/4, 1 plus 1/4 is going to be 1 and 1/4, which also equals 5/4. I always prefer improper fractions instead of mixed numbers. And so now I'm going to think of that as 5/4. Okay, so now we've got 12 times 5/4. 12 times 5/4. 5/4. So 12 times 5 is 60. 1 times 4 is 4. And 60 divided by 4, top divided by bottom, is going to be 15. Which is, yay, we got it. Okay, so then D is also equivalent. All right, so E. All right, now E, I know I'm a teacher, so I see these things right away, but I'm multiplying 12 times a fraction that's less than 1. So I know that is going to result in a number that's less than 12. All right, so it's going to end up in something less than 12. But don't take my word for it. Let's look at the math here. 12 times 3 is 36. 1 times 4 is 4. And 36 divided by 4 is 9. And that is not going to work. Now for F, the thing that pops out at me here is that looks very much like what we ended up with right here when we did 12 times 5/4, because 1 and 1/4 as a mixed number was 5/4. So I'm glad I did that, because that looks just like F, and that tells us that F is equivalent. Isn't that cool? That works every time. All right, for number 3, write a story that can be represented by the equation y equals x plus 1/4 x. All right, so it's kind of putting me on the spot here. I have to think To think. I don't know. Let's say X represents, let's say it represents like a bungee cord or something. I don't know how to spell bungee. Is it two E's? I'm just going to say elastic. How about that? Elastic cord. Okay? X equals the length of the elastic cord. And we know that that cord can stretch a fourth of its length. Okay? So how far can 40 feet of cord stretch in all? I don't know if I worded that right. That's not the best wording there, but you guys know what I mean, right? So 40-foot cord. So X is the 40-foot cord plus 1/4 of 40. All right, so 1/4 of 40 is 10. So 40 plus 10 equals 50. So 50 feet, and that makes sense. All right. Number 4, select all ratios that are equivalent to 4 to 5. Now what I want to do for this one is, and I don't know if I'm doing it too early, but let's go ahead and do it. I want to show you, let's set up proportions here. Because this is asking us, let me move this over, oops. It's asking us for all ratios that are equivalent to 4 to 5. So 4 to 5, like that. And, you know, when we set ratios equal to one another, those are called proportions. Proportions are equal ratios. All right, and so we can just set up proportions here. And the reason I like proportions is because they have this thing called cross products. Cross products are, you know, when the cross products equal one another, when they're equal, when they're equivalent, that means you have a true proportion that is equal on both sides. Therefore, the ratios are equal, thus making it a proportion. That's kind of circular logic there, but I hope you know what I mean. So we got 4 to 5, and then 2, and then 2.5. 2.5. Now 5 times 2 is really easy. 5 times 2, you know, when I multiply that left to right, that's, you know, that's 10, right? So this part right here, 4 times 2.5, that's also 10 right there. So I am going to choose A. Choose A is equivalent. So it says select all. So we can't just stop there. Let's keep going. All right, let's see about C. Let's do the same thing. I'm going to do 4 to 5 and set that to 3 and then 3.75. All right, and so I know that 5 times 3 is 15. So what I'm going to do is I'm just going to do 3.75 times 4, and that should be 15, right? Yep, it confirmed it. It's 15. All right, so when we cross multiply, you know, we get 15. Well, that you don't have to draw like really fancy bubble arrows and stuff like that, but yeah, that's going to work as well. And sorry, for whatever reason I skipped B. And I think it was just because my mind telling me it's not it, but yeah, it's got the same, see how it has a 2 there, but doesn't have the same number here? Well, then that can't be it. So B is, we can just get rid of that. Get that out of here. What's it think it's doing? All right, I'm going to make some room here. And I'm going to do 4 to 5 and 4 to 8. Now, if just do cross products here, 5 times 7 is 35. 35. And then 8 times 4, that's also 35. No, it's not. It's 32. It's 32. So those are not equal. Therefore, that's not a proportion. Those are not equivalent. Okay. 8 to 10, and I'm not even going to do cross products for this one. You can just tell by looking, right? You can just see it. You can see it. 4 times 2 is 8, right? 5 times 2 is 10. So 8 to 10 is got to be equivalent as well. All right, and then we're last stuck with 14 to 27 and a half. So I'm going to keep doing this, 4 to 5, and I'm going to do 14 and then 27.5. Now 5 times 14, because I know my 5 tables, right? You guys all know your 5 tables. So I know 5 times 10 is 50. 5 times 4 is 20. 50 and 20 makes 70. Okay, so right there, that makes a cross product of 70. And then I'm already thinking that this is not going to work because 27.5 times 4 is going to be over 100. I know that. So 27.5 times 4. Oops, I think I put an artifact in there. Let me try again. 27.5 times 4. And that's going to be 110. Okay, that does not work. Okay, so those are not equal. They don't make a proportion, therefore they're not equivalent. Okay. And then for number 5, Jada is making a circular, or she's making circular birthday invitations for her friends. The diameter of the circle is 12 centimeters. She bought 180 centimeters of ribbon to glue around the edge of each invitation. How many invitations can she make? I bet she can make like 1,000, right? I don't know about that. But this is, this is one of those questions that's asking us to figure out circumference. Nowhere in this problem does it say circumference. But it does say that she's making circular birthday cards. They're a circle shape, and she's putting ribbon around the edge. Okay, it doesn't even mention perimeter, but this is definitely a circumference problem. This is circumference. So when we do circumference, we're going to do pi times diameter. It's a very simple formula for circumference. So let's figure out the circumference of one invitation, because then if we know what one invitation is, we can figure out how many of those invitations we can make. All right, so we can do that. So we can do, let's just do 3.14 times, and I never even drew a picture of it, not that you need it, but so the invitation is, the diameter of it is 12, right? The diameter is 12, and so we're going to do 3.14 times 12. All right, and that's 37.68 centimeters. So just one of those invitations is going to be 37.68. All right, I can do this. I can do 37.68 times, try that again, 37.68 times 2. All right, that's 75. All right, I'm looking for a number that, as long as it doesn't go over 180, we're good. All right, so that didn't work. So I'm going to try times 3. Let's see, 113. Okay, we're still not over 180. Let's just scratch it off. I'm going to try times 4. That's 150. All right, we're getting closer. Scratch it off. I'm going to try 5 this time. All right, that's too much. So 4 is the magic number, and we can't round this, right? We can't round it. Like, let me go back to the 5 for a second. 5, that doesn't work. I can't just, round that down. We only have 180 centimeters of ribbon to work with, so it's got to be 4. It's got to be 4. And look how weird this program is sometimes. It just makes really weird notation sometimes. But oh, look at that, even crazier. All right, I don't think I scratched it out well enough. There we go. So 4 invitations. which is good because that's all Jada has. She only has 4 friends. All right. No, I don't know that. She's probably going to need more invitations. Maybe she only has 4 friends. That's okay. It's okay to have that. All right.